Hi there. In this video, we're going to be graphing a couple quadratic functions. We're also going to look at the properties of the quadratic function that we graph, like our axis of symmetry. We're going to name our domain and the range of the function as well. So let's get started. In the blank space of your notes, I want you to write this quadratic equation. And then if we look at the standard form of a quadratic equation compared to what I gave you, you'll see here we have the y equals, I had you write down 1/2 x squared and then minus 3. So you'll see that the b value is missing, and that's because the b value is a 0. Okay? Now, when you're graphing this, you need to come up with a table of values so you have some points. It's generally really good to have 5 points, one being your vertex point, and we want to find our vertex point first. And I just put that point right here in the middle of the table because remember that's kind of the middle point of your parabola. So in order to find the vertex, we can use a formula, and that formula is right here. X is equal to negative b over 2a. That formula is going to give us the x coordinate of the vertex. So I'm going to write down x equals, I'm going to look at my function, and it says negative b. The b value, remember here, is 0. So negative 0 divided by 2 times a, and a is 1/2. And so this would really be negative 0 over 1, which would just be 0. We don't really have negative 0. So the x coordinate is 0. So I'm just going to put right in my table here 0 for the x coordinate of the vertex. Now, how are we going to find the y coordinate of the vertex? Well, you're going to take the 0 and you're going to plug it into the quadratic function right here in place of x, and you're going to evaluate for y. So what is 1/2 times 0 squared minus 3? And well, that's going to be negative 3. So I'm just going to erase what I did here. Okay, so now once you have the vertex, I'm just going to go over here. I'm going to graph that. So 0, negative 3. And we know that our parabola is going to open upwards. So this is going to be the lowest point. That's our minimum point on the graph. So now I'm just going to pick two numbers above the 0. So I'm just going to go 1 and 2 for my x coordinate, for my x values, and then negative 1 and negative 2. Now, these are your domain values, right? These are our domain values, our x values. And you could plug any number that you wanted into the function for the domain. So x could be anything you want. I'm just picking numbers close to that vertex. So then what I'll do is I'm going to take each of these numbers, negative 2, negative 1, 1, and 2, and I'm going to plug them into the function for x, and I'm going to evaluate what y is equal to. So just like when you've made a table of values for other functions, okay? So if I plug in negative 2 in here, remember when you're plugging in negative 2, think I want parentheses around the x. I'm taking negative 2 squared. So if I plug in negative 2 squared times half minus 3, use a calculator if you want to, you get negative 1. If I plug in negative 1 and square it, multiply it by half, and then minus 3, I would get negative 2.5. So calculator is very useful for this, okay? Now, when you plug in the positive numbers 1 and 2, and you plug those in for x and you're squaring it, it's going to be the same answers that you got for the negative 1 and negative 2. Because remember that when you're graphing a quadratic equation, remember those parabola is symmetrical. So you're going to see symmetry in these values here. So then I'm going to go over here and I'm going to graph them. So negative 2, negative 1, negative 1, negative 2.5. 0, 3 is already on there. 1, negative 2.5. And then 2, negative 1. So there we go. I've got 5 points on my parabola. So I'm just going to kind of sketch the graph here. And this is how you would do it without using a calculator. You're just going to make a table of values, finding the vertex first, and that would be your first point that you find. Okay, so now let's talk about axis of symmetry. I'm going to just go ahead and draw the axis of symmetry right here. Remember, that's that vertical line that goes right through the vertex. Now, with the axis of symmetry, it's going to be an equation. So we want this equation. We can see that it goes right through the x-axis. And so it's going to have an x in the equation. It goes right through point 0. So the axis of symmetry would be the equation x equals 0. Okay. Now domain is all the x values. So all the x values that I plug into the function. And remember, we talked about x values could literally be anything. So when you're looking at domain values, you're going to say all real numbers. X could equal all real numbers. You could plug anything in that you want for x into the function. But the range is a little bit different. because the range is your y values. So when you look at the actual graph here and you look at y, the lowest point on the graph, whoops, the lowest point on the graph, back up. I think I hit the wrong button. Okay, the lowest point of the graph is the vertex right here, and that's the point 0, -3. So the lowest y value that we're going to have is -3. And then it goes up from there, both directions, right? The parabola goes up. It's never going to touch any other y coordinate that's less than -3. And even if you look at your table that you made here, do you see how -3 is the lowest number? So the range is going to be y values that are greater than or equal to -3. Everything bigger than or equal to that -3. So range is going to be written as an inequality. Okay, so here's one example. We're going to go to the next one that you had a sneak peek of because my slide moved. Okay, let's try this one. So I want you to write this quadratic function into that blank box. Let's graph this one. Now, here's our standard form, and if I write down what I gave you, it's y equals -2x squared and then plus 4. Okay, so again, do you see how the b value is a 0 right here? Okay, so same type of thing. Now, but do you also notice that the a is a negative number? So our parabola is going to be opening downward, isn't it? Okay, so if we're making a table to graph this, the first point that we want to find is our vertex. So in order to find the vertex, I'm going to use the formula here. I'm going to find the x coordinate first. X equals negative b, which is -0. Remember, this is the b. And then I want to take it 2 times a, and the a is -2. So this would be -0 over -4, which would be 0 divided by 4 is just 0. So I'm getting 0 again. Okay, there's 0. Now I'm going to take that 0 and I'm going to plug it in for x into the quadratic equation. I'm going to solve it for y. Well, as soon as I multiply, as soon as I square 0, multiply it by -2, it all goes away. So I'm going to get 4 here for my vertex. All right, go ahead and plot that. Let's plot that on the coordinate plane, 0, 4, way up here. Remember, this has a -2a value, so it's going to open downward. So this vertex is going to be a maximum point at the very top of the graph. Okay, so now we're going to come up with 4 other points. And if our vertex here is 0, we're going to use the numbers 1 and 2, just the next consecutive numbers above 0, and then -1, -2. All right, so the 2 numbers that are below. And then we're just going to take these x values and we're going to plug them right into the function for x. So this time, let's plug in the positive values, like 1. If we plug in +1 for x, square it, multiply it by -2. I'm just following order of operations, and then add 4. If you do that, you're going to end up getting 2. Let's plug in 2. When I plug in 2 in for x, square it, multiply it by -2. You get -4. Now remember, this is symmetrical. So if I were to plug in -1 and -2 into the function and you square them, it's going to give you the same answers as you would have when you got when you plugged in 1 and 2. So we're going to have the same answers, and this is going to create the symmetry in the parabola. Okay, so let's graph -2, -4 right here, -1, 2. I've got the vertex right here, 0, 4, 1, 2. And 2, -4. All right, so there we go. I'm going to connect the points. And there's my parabola opening downward right there. Now, check this out. This is kind of cool. You see this +4 right here? Where do you see that in the graph? Ah, it's the y-intercept, isn't it? Take a look at your example that we did previously. That -3, was that also the y-intercept of the graph that we did just before? I think it was. Okay, axis of symmetry. I'm going to switch colors here. All right, axis of symmetry goes right through the vertex. Again, whoops, that's not very straight, but you get the point. It's an equation. It only goes through the x-axis at point 0, so it's going to be the equation x equals 0. As soon as the parabola starts moving right or left on the graph, our axis of symmetry is going to change. Okay, now domain, remember domain can be any x value that you want. All day long, you could plug in any number that you want, so our domain is always going to be here, all real numbers. Domain, all real numbers. Range is your y value. So let's take a look at the graph. Do you see how the maximum point, that y value of 4, that's the highest y value that you're going to have, because then the parabola goes down from there. So even if you look at your y values here in the table, 4 is the biggest number, and then it goes down from there. So our range, if 4 is the greatest number and we're writing an inequality, it's going to be y has to be less than or equal to 4. And those would be all the y values that the parabola is going to be touching as you graph it. All right, so there we graphed another one. I think we are ready for our summary. Let's summarize here. Okay, the graph of a quadratic function makes a parabola. Yes, and we know that the standard form of a quadratic function looks like this. And the a tells us if it's positive, it's going to tell us the graph opens up. And if the a is negative, the graph opens down. We saw that in a couple different examples. Okay, next to the parabola here, let's label some of the parts. That vertical line that goes straight through the center, creating symmetry, is our axis of symmetry, and we always write it as an equation, x equals. Then the point down at the bottom there, that's representing the vertex where the parabola starts to change direction. And remember, the vertex can either be a minimum value or it could be a maximum value, depending on the direction of the parabola, if it's opening up or down. Then we talked about domain and range. And domain, remember, that's your x values, and that's all real numbers, always. X equals all real numbers. Your range is talking about your y, and the y values are going to be written as an inequality. So y is written as an inequality. Then lastly, we looked at the vertex formula. In order to find the vertex, we use the equation x equals negative b divided by 2a. That gave us the x coordinate of the vertex, and from that we could then plug it into the function and get the y coordinate. That's the very first point that you find when you're graphing a parabola without using a calculator, so by hand. So we're not using a graphing calculator if we do it on paper. Okay, if you need to pause the video to write down the summary, go ahead and do that. Thank you so much for joining me for this lesson video. Have a great day.